A uniform rod of length L lies on a smooth horizontal table. A particle moving on the table strikes the rod perpendicularly at an end and stops. Find distance traveled by the center of the rod by the time it turns through a right angle. Show that if the mass of the rod is 4 times that of the particle, the collision is elastic. Suppose the particle of the previous problem has mass m and speed v before the collision and it sticks to the rod after the collision. The rod has a mass of m. Find the velocity of the center of the mass c of system constituting the rod plus particle. Find the velocity of the particle with respect to c before the collision. Find the velocity of the rod with respect to c before the collision. Find the angular momentum of the particle and the end of the rod about center of mass c before the collision. Find the moment of inertia of the system about the vertical axis through the center of the mass c after the collision. Find the velocity of the center of the mass c and the angular velocity of the system about the center of the mass after the collision. A uniform rod AB 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 is equal to L and mass of rod M. Particle कोलाइड करता है, इसका मास m, स्पीड इज v, ये सेंटर O of the rod, suppose center of mass, this is c and this distance is x. AB रोड का मास हम यहाँ एक्टिंग एट O एज्यूम कर सकते हैं एंड दिस इज L/2. OB is L/2. तो X will be equal to ML/2 upon M plus M or ML upon 2 M plus M. Suppose this is X1. So X1 will be OB minus X. OB is L/2 minus ML/2 M plus M, and this comes to be small L/2 M plus M. Part A. Question A. Find the velocity of the center of mass C of the system constituting the rod plus the particle. Initial speed of particle m, the velocity of particle m, particle of mass m is equal to v. velocity of road is equal to 0. So velocity of center of mass V is equal to m1 v1 plus m2 v2 upon m1 plus m2. This is formula. m1 m into v plus m into 0 upon m plus m. This is mv by m plus m. The velocity of center of mass is v is equal to mv upon m plus m. Next, find the velocity of the particle with respect to the c before the collision. Velocity of particle with respect to c before collision. That will be v vector minus capital V minus mv by m plus m or mv by m plus m. C. Find the velocity of the road with respect to c before the collision. Velocity of road before collision Vr, and that is 0. Velocity of center of mass v is equal to mv by m plus m. Velocity of road with respect to velocity of center of mass c. This will be Vr vector minus V vector 0 minus mv by m plus m minus mv upon m plus m d. Find the angular moment of the particle and the road about the center of mass before collision. AB road, particle mv, O, this is C, x, where x is equal to ml by 2 m plus m. Velocity of center of mass, center of mass C, that is mv by m plus n. In this direction, velocity of particle is equal to v. Velocity of particle with respect to center of mass C. This will be v minus mv upon m plus m, or mv upon m plus m. So suppose this is Vp. Angular momentum of particle about the center of mass C. Mass of particle, velocity of particle with respect to center of mass Vp into distance between center of mass and the particle, that is x. M Vp is mv upon m plus m, and x is ml upon 2 m plus m. M square VL by 2 m plus m. Next, angular momentum of the rod, angular momentum of the rod velocity of rod with respect to velocity of rod with respect to center of mass C, that is minus mv upon m plus m, as per part part C minus mv upon m plus m. Suppose this is V road. We are distance between center of mass C and center of mass of road, that is minus x1, and minus x1 is minus x1 is ml upon 2 m plus ml upon 2 m plus m. Mass of the road m, angular momentum of road about center of mass C, that will be m into Vr into x1. M, Vr is minus mv upon m plus m, and this is minus ml upon 2 m plus m. M square VL upon 2 m plus chi square. This is square. This will be angular momentum the road about C. Next part E. E part. Find the moment of inertia of the system about the vertical axis passing through center of mass about the after the collision. This is the road AB, the center is O, here is M mass, यहाँ पर ये center of mass C, this distance is x and this is x1. X is perpendicular to AB and passes through the C. IC will be mx square, moment of inertia of this particle, plus IO, moment of inertia of the road, and this is suppose D and D is x1. IO plus md square. Mx square plus IO will be ml square by 12 plus m x1 square. M x is ml by 2 m plus m square plus ml square by 12 plus m small ml by 2 m plus m का स्क्वायर, m square l square by 4 m plus m का स्क्वायर प्लस ml square by 12 plus m square l square by 4 m plus m का स्क्वायर। इसको प्लस कर दें, दिस मच इन दिस, एलसीएम 4 m plus m का स्क्वायर m स्क्वायर l स्क्वायर प्लस m स्क्वायर l स्क्वायर प्लस ml स्क्वायर बाई 12, l स्क्वायर m प्लस m अपॉन 4 m प्लस m का स्क्वायर प्लस ml स्क्वायर बाई 12, क्रॉस हो जाएगा आई सी 12 m प्लस m m l स्क्वायर 3 प्लस m l स्क्वायर प्लस m स्क्वायर l स्क्वायर 4 m l स्क्वायर प्लस m स्क्वायर l स्क्वायर अपॉन 12 m प्लस m l स्क्वायर 4 m प्लस m अपॉन 12 m प्लस, this is moment of inertia of the system about C. This is IC. Now, F part F. Find the velocity of the center of the mass C and the angular velocity of the system about the center of mass after the collision. F. Velocity of center of mass after collision. Initial Pi is mv plus m into 0 is equal to mv. Final Pf, linear momentum will be m plus m into v, and Pf is Pi equal to Pi, so m plus m into v is equal to mv, and v is mv by m plus m. This will be the velocity. Angular velocity of the system about C. velocity of this C is mv upon m plus m. Velocity of B is v and this is 0. Velocity of particle with respect to center of mass C, v minus mv upon m plus m or mv upon m plus m. Velocity of rod with respect to C, 0 minus mv by m plus m. So minus mv by m plus m. Suppose this is Vp and this is Vr. एक रोड AB, center O, C, की velocity in this direction Vp and O की direction Vr. This is x, this is x1. Angular momentum about C. Mass, this is m, capital M. LC is mvp into x plus mvr into x1. mvp is mv upon m plus m and x is equal to this x ml by 2 m plus m plus m into mv upon m plus m into ml upon 2 m plus m. m square vl upon 2 m plus m plus m square vl upon 2 m plus m का square. 2 m plus m का square m vl m plus m plus m plus m vl by 2 m plus m. And as per this C part, E part, IC is ml square 4m plus m, 4m plus m, 12m plus m as per part E. Then LC is IC into omega. LC is mmVL by 2 m plus m, and IC is ml square 4m plus m, 12m plus m omega. This is 6m plus m से m plus m, omega m capital M से capital M L से एक L. mv 6mv upon L 4m plus m. This will be the angular speed, 6mv upon L 4m plus